Hello boys and girls, I'm teacher Regan. Welcome to Easy Elimu Learning Simplified. I hope you are fine this afternoon. Today we are going to talk about prime numbers. In our previous sessions we discussed odd numbers, we defined what they are. We talked about even numbers, and we realized that odd numbers, as we agreed, are numbers that whenever divided by 2, there must be a remainder. In other words, they cannot be completely divided by 2. Even numbers, we say that these numbers are numbers that are completely divisible by 2. In other words, when you divide an even number by 2, there will be no remainder. Number like 4, 6, 8, 10, 12, 24, etc., etc. Odd numbers are numbers like 3, 5, 7, 9, 11, 15, 17, etc. Whenever you divide them by 2, there will always be a remainder. We also realize that when you add an odd number to an odd number, then the sum is even. And equally, when you add an even number to an even number, the sum is equally even. So, what about this prime number? What is prime numbers, or what are prime numbers? Someone to try? What do you think are prime numbers? Yes, Angela, what do you think are prime numbers? A number? Good. A number, that is encouraging. A number, a prime number, introduction. A prime number is a number with only 2 divisors, semicolon, 1, write 1 figuratively in bracket, 1, and the number itself. So this is a number with only 2 divisors. And these 2 divisors is 1, the number 1, and that particular number itself. It means when you want to divide this number, you can only divide it by itself and 1. Are we communicating? Yeah, that is a prime number. So can we please maybe identify some of these numbers between 1 to 10? Examples of prime numbers. Examples of prime numbers. A, 1 to 10. Examples of prime. Give me those numbers between the bracket 1 to 10 that cannot be divided by any other number apart from the number 1 and the number itself. For example, if you have the number x, the only number that can divide the number x is x, which is itself and 1. Then that is a prime number. Let us look at number 4. Give me the list of numbers that can divide number 4, or otherwise the divisors or factors of 4. We have 1, 1 can divide 4 4 times. We have 2, 2 can divide 4 2 times. And we have 4 itself that can divide 4 1 time. So 4 is not a prime number because it has got 3 divisors, 1, 2, and 4 itself. Are we communicating? Good. Let us look at the number 6. How many numbers can divide 6? We have the number 1. Before, let us look at 4. We have said 4 is divisible by 1. This 4 is same as divisible by 2, and it's also divisible by 4. So is 4 a prime number, class? No. Why? Because it has got 3 divisors. And we have said a prime number is a number with only 2 divisors. So this is not a prime number. Let us look at the number 2. How many numbers can divide 2? 1, correct. 2. Any other number? No. So how many divisors does 2 have? 2. Cool. That is a prime number. Let us look at the number 5. How many numbers can divide 5, class? Yes, Peter? 1, correct. 1 divides 5. Yes, Angel? 5 itself, correct. So it has got only 2 divisors. So using the same criteria, let us identify the prime numbers between 1 to 10. So as we can see, the first one is 2. That is the least prime number, by the way. The second one is 3. 3 can only be divided by 1 and 3 itself. The third one is 5. The fourth one is 7. Someone has said 9. Is 9 there? Let us confirm. 9. Give me the numbers can go into 9. We have 1, correct? Yes. 3, good. And any other? 9 itself. How many divisors or factors? 3. Therefore, 9 is not part and parcel of this first set. Correct. Let us look at the prime numbers between 10 to 20. All right. Let us check 10. How many numbers can divide 10? 1, 2, 5, and 10 itself. Is it a prime number? No. So 10 is ruled out. So here we are going to have 11. We shall have 13. Is 15 there? No. Why? Because 15 can be divided by 1, 3, 5, and 15 itself. Those are 4 factors. And we only need a number to have how many factors? 2. So 15 is not there. We have 17 and 19. Those are some of the prime numbers between 10 to 20. Let us look at the prime numbers between 20, or let us discuss 50 to 100. 50 to 100. Not really. Let's do 20 to 50. See? 20 to 50. The first one, 21, no. It can be divided by 3, 7, and 21 itself. 1 is also included. So our first prime number here is 23. 25, no. It has got so many divisors, 5, 4, 5, 1, and 25 itself. 27, no. 3 is a divisor of 27 or a factor of 27. 9 is a factor of 27 and 27 itself plus 1. Those are 4 divisors. 28, no. We have 29. We have 31. 33, no. 33 has got so many factors, 11, 3, 1, and itself. Those are 4 factors. 35, no. 7 is a factor. 37, yes. 39, no. We have from 37, we have 41, 43, 47. So those are some of the prime numbers between 20 to 50. Are we together, class? Good. So there is normally this question that most students tend not to do well, whereby you are told to express a number as a product of its prime factors. The key word in that question is prime factors. So for example, you can be told express, let me use a very simple example. Express 24 as a product of its prime factors. The keyword here is prime factors. You cannot express this in terms of any other factor unless it is a prime factor. So here we encourage most of the learners to use the factor tree method, So solution. So we use factor tree method whereby we have 24, then you draw an inverted V that represents our factor tree. So you ask yourself, what is the first prime number that can divide 24? That is your guideline. This is what guides you. So the first prime number, as we said, is 2, and 2 can divide 24. So we have 2 into 24, 12. 2 can still go into 12. So 2 into 12, 6. 2 can still go into 6. So 2 into 6, 3. So allow me to continue on this side. So we are at point 3, and the only number that can go into 3 is 3 itself, 1. Therefore, 24 expressed as a product of its prime factors is, you can see 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. 2 times 2 times 2 is 8. 8 by 3 is 24. You can equally write this in index form, whereby we have 2. How many are they? 1, 2, 3. So the exponent of 2 becomes 3 times 3. If you leave it at this point, you will not score because you will only have used the factor 3 method, but you will not have written it as a product. Another example. You can be asked to express, this is example 1, example 2, express 120 as a product of its prime factors. So here solution. So we use factor 3 method, whereby we have 120. So you identify the first even number, and not really even, sorry, the first prime number that can divide 120 without a remainder, and that is 2. 2 into 120, 60. 2 can still go into 60, 30. 2 can still go into 30, 15. So after 2, the next prime number that can divide 15 is 3. Because 2 divides is, yes, but there will be a remainder. We don't encourage remainders here. So we move to 3, our next prime number. 3 into 15 is 5. So the next prime number that can divide 5 is actually 5 itself. So 5 into 5, 1. So this implies that 120 expressed as a product of its prime factors is 2 by 2 by 2, which is 2 times 2 times 2 times 3 times 5, which is 2 raised to power 3 times 3 times 5. So that is how we apply the concept of prime numbers. We mostly apply prime numbers whenever we are solving LCM. We are expressing a number as a product of its prime factors. Otherwise, that marks the end of our discussion regarding the prime numbers. Maybe if you do not have a question, allow me to give you some of the exercises, just a few for your personal revision. Express the following numbers. As a product of their prime factors. A, 36, B, 81, C, 49. That was number 1. Number 2, list all the prime numbers. List all the prime numbers between 50 to 100. List all the prime numbers between 50 to 100. Otherwise, that marks the end of our discussion today. When we meet next time, we'll discuss something else. Have a nice afternoon.